This is the video for Mod 9 Lesson 1, Dilations. The focus of this unit or topic is going to be on similarity. So one of the sections we're going to look at today is dilations, which is a transformation of a figure on the coordinate plane in which you're enlarging or reducing the size, right, proportionally. So the goals we're going to look at is basically talking about scale factor, so identifying the scale factor for a dilated figure, and also using that scale factor to dilate a figure on the coordinate plane. First, we're going to talk about what a dilation is. So like already mentioned, so a dilation is a transformation, and what we're doing with the figure is enlarging or reducing it. And by doing that, you're going to find that we're going to end up with two figures. The corresponding angles, or the angles that match up with each other, are still going to be the same size or congruent. And then the sides that correspond or match up are going to be what we call proportional. So what that means is that if I compare the length of those sides, you'll get the same ratio or scale factor. So everything's increased or decreased by a multiple. So the original figure, just so we kind of know the terminology, we call the original figure, we start with the pre-image, and the image we create, we a lot of times call the image or just the new image, and we're multiplying by a scale factor that we're calling k. So if we find that our value for k, or sometimes it's called n, is greater than 1, so let's say I'm doubling the size or tripling the size, that would be a scale factor of 2 or a scale factor of 3. That's going to make the figure larger or create an enlargement. So an example of that would be if I had, like, let's say 2 or 3 as my scale factor. If our k value is between 0 and 1, so let's say I had k as a half or a third, that would be a reduction. So that's going to be taking half the size, or a third of the size, or a fourth of the size, or 3/5 the size. So anything less than 1 is going to create a smaller figure that's similar, meaning that the sides are proportional and the angles they match up are still the same. So one example you might see is where if they give you a diagram, you're really just going to match up the corresponding sides and compare them. So in this example, we would see IJ has a length of 1, and then we call the new image HIJK prime, right? So when I do a transformation, note I don't want to put a whole new set of letters, but I can't just call this HIJK. So we use a little apostrophe, and that's basically saying H prime, I prime, J prime, K prime. So our new figure, it's actually not a triangle, sorry about that, it's actually a trapezoid, we call it with HIJK prime. So our original figure had a 1. Our new figure, we see that this is 2 units. I recommend counting the vertical or horizontal. Counting the slanted isn't going to really work as well for getting an accurate answer. And so when we do our scale factor, we always do the new image over the old. So it's always new over old. That's what I tell people. Or the image over the pre-image. So our new image is 2. Our old image had a corresponding side of 1. So our scale factor is actually 2 to 1, or 2. If I did that with any of the other sides, if I wanted to check, you would see this one is a 4 at the bottom. This one ends up being an 8. And you would get the same answer if you did 8 over 4 or 2. So it doesn't matter which corresponding sides you use, you're going to get the same scale factor. So definitely using the horizontal or vertical lines will be easier. Our scale factor is 2, which is obviously bigger than 1. And you can see it made a larger image, so we would say that's an enlargement. It made everything bigger proportionally. So this example is very similar to the one we just did. So what you're going to do if it says determine the scale factor, you're going to just pair up the corresponding sides and compare them. And remember, we always do the pre-image over the original image. Or another way to think of it is it's the new over the old, same thing. And so our new image, if I count it, that's my red. So I have triangle RST prime. And you can, if I count it, I have 1, 2, 3, 4, 5, 6. So my new image, if I take one side length, that was 6. The old one, this would be the corresponding side, and that's a 4. So my scale factor, sometimes I like to write SF for scale factor, but our scale factor would be 6 over 4 or 3 over 2. We always like to reduce our scale factor. And if we can write it as a ratio, we want to. If you write 1.5, it's not technically, we know what you mean, but usually we tend to like to keep them as a ratio of 2 integers when we can. Now we're going to look at what happens when we actually have want to dilate a figure by a scale factor. So the notation that we're going to see a little bit in this section is this little capital D for the word dilate. And so if I want to dilate by a scale factor of 2, you're going to see it with a little subscript, kind of like you would see in like a chemistry class. So D sub 2, which basically means dilate triangle CDE by a scale factor of 2. So this tells us this little subscript is going to be our scale factor. Okay, so if I look at my problem here, we could basically create this new image. So I can see, like, for example, point C is -2, 2. Point D is a negative, or actually, point C was -2, 2. Point D was -2, 2. And point E is 2, 1. And so when it says dilate by a scale factor of 2, all that basically means is you take all these values and multiply by 2. And then we're going to even check it on the graph to make sure that's correct. So you're basically taking all those and just multiplying every single value by 2, because that's our scale factor. So I would get -4, -4. I would get, now I'll actually write it down here, so -4, -4. D prime would be a -4, 4. And E prime would be 4, 2. If I wanted to check my answers correct, I can see, well, C prime is actually -4, 4. D prime is -4, 4. And E prime was 4, 2. So it actually did check out. So really, if they give you a scale factor, you're just multiplying all the values in the coordinate points by the scale factor, and you're creating your new image. This example is very similar, where you're given the points and you have to write the original image or the pre-image, or the original image, and the new image after it's dilated. So we can see triangle ABC. We have a point at -2, 4. So and we always like to label our points. So this was A. B was 2, 6. And C is 4, 0. So if I connect it, I got something like this. And so the dilation is for a dilation of 1/2. So if I take these points, so I have A, -2, -4, B, 2, 6, C, 4, 0. I'm now going to multiply all of these by 1/2, which is actually the same as dividing by 2, essentially, right? So it's like, really, when you're multiplying all these by 1/2, and maybe you don't have to rewrite it all, it's really like dividing by 2. So A prime is going to be -1, -2. B prime is going to be 1, 3. And C prime is 2, 0. So when I graph it, it should look similar to this figure in shape, and all the angles will be the same, but the sides will be all a reduction of 1/2, right? So -1, -2. This would be my A prime. We have 1, 3, which is B prime, and then 2, 0, which is C prime. And you can see it's the same shape. The angles are the same, and the sides it's a reduction because our scale factor is 1/2. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.